Hmm. Yes. Mm-hmm. 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 Okay. Mm-hmm. No, 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 no. It's totally wrong information. Actually, yeah, this is your Earth surface, and then you have troposphere, and then you have stratosphere. In troposphere, your temperature will decrease. At mean sea level, you will consider 288 Kelvin temperature, and here in I mean the last level of temperature 216.5 Kelvin, and after that the same temperature will be maintained in stratosphere. Yeah, and why temperature is decreasing here? Because just now, I mean in previous class we have discussed like temperature is proportional to pressure and density, right? In this way, so if pressure will because pressure is decreasing and density is also decreasing, but pressure decrement is dominating, that's why temperature is decreasing. But in case of stratosphere, this decrement and this decrement, they are giving same effect, that's why temperature is maintained here same. So rough height, yeah, one thing can be different in every textbook, like this height value. So standard value is like 11 kilometer you can consider. In some textbook they consider only 10 kilometer, and here you can consider 25 kilometer, like this. So these are the standard values. Sometimes they can say 22 kilometer, sometimes 23 kilometer. It depends on north or water. So yeah, I take as 11 and 25. Yeah. Yes. Next doubt. Mm-hmm. Mm-hmm. Right, right. Mm-hmm. Mm-hmm. Okay. Okay. So now, okay, I got it. Actually, see, whenever we are learning anything as in aviation, so it is a international subject. So if something is international subject, then we should follow SI unit. So if you are referring any special book, and then it depends on their country requirement. Concept will be same, only unit will change. I mean everything is same. Yeah, it's like you can talk about 0 degrees Celsius, or you can convert it to 273 degrees Celsius. So there are conversions, there are some ways we can convert one unit to another unit. So unit is not a big problem. Concept we can go, because concept is going to be same. Concept is going to be same. Yeah. So yeah, next doubt. Right, right, right. Yes, yes, pressure is equal to rho RT, correct. Correct, 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 correct. Correct, correct. Correct. Mm-hmm. Mm. Mm-hmm. Very good, very good. Mm-hmm. Okay, see here. Equation is this. Temperature is proportional to pressure and inversely proportional to density, right? Directly proportional means if you will decrease the pressure, temperature will decrease, and according to density it is inversely proportional. So if you decrease the density, temperature will increase. Mathematically, this is the logic. Right. Right. Yes. So that's why same phenomena is happening in troposphere also and in stratosphere also. Actually, if you consider this is Earth's surface and this is troposphere, so in troposphere, when you are going up, pressure is also decreasing, density is also decreasing. It means both are decreasing. Because of that, because of the pressure, temperature is decreasing, but because of density, temperature is increasing. So overall effect is temperature is decreasing. Why? Because the decrement in P is dominating. Okay. But if you go for the stratosphere, again, in stratosphere, when you travel the altitude, your pressure will decrease, your density will decrease. But their decrement will again affect the temperature in the same way. Because of pressure decrement, temperature will decrease. Because of density decrement, temperature will increase. But, okay, actually, are you using Wi-Fi or you are using your mobile data? From my side, no problem. Are you using mobile data or Wi-Fi? Are you using mobile data? See, that's what I am saying. Are you using mobile data? Maybe there is network issue your side. Because I am using Wi-Fi, so I don't have a network issue. You can see, you see here. This is Wi-Fi, right? I'm using Wi-Fi. Oh. Okay. So you do one thing. Okay, fine. Then. Okay. Then you join again. Yeah. Yeah. Yes, Dinesh, am I audible now? Yes, Dinesh. Yeah, am I audible now? Am I audible now? Actually, everything is clear from my side. Yeah, Dinesh. Yeah, I can hear you. Okay. Yeah, ask your next doubt. Yeah, okay, okay. I will go again. See now, this is your Earth surface. Huh. Right, 288. What? Say again, say again. No, not maximum. Temperature is 288. When we are doing study, we should. Right. But it will not decrease in all the atmospheres. It will decrease only in troposphere. Yeah. And then, yeah. Correct. Correct. Hmm. Right. 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 Okay. So now I understand. I understand. Actually, see what mistake you are doing. You are only considering density as the factor to affect the temperature. Density alone is not responsible for the temperature. At the same time, you should talk about pressure. So this temperature is the effect of both pressure and density all together. They are making this temperature. Both together they are making the temperature. So density is maximum here, but in that sense you cannot say, sir, here density is minimum, so here temperature should be maximum or something else, because both together combined effect is giving you this variation. In troposphere temperature will decrease, and in stratosphere it will be constant, and then it will increase. So actually after that we don't have to discuss. Okay, done. So next doubt. Okay, now see, actually there is something called density, right? So density of hot air is going to be less than density of cool air. What is the right logic? See, right logic is, you can take in this way. Your P is equal to rho RT equation is given. So if you relate this density and temperature, then you send density down, so you can see, or you send temperature down. So your density is actually inversely proportional to temperature. So if your temperature is more, then density will be less. It means for hot gases temperature is more, so density is less. So this is the physical, a mathematical way to explain, but you can also understand physically. How will you understand physically? See, suppose you have one chamber. So no, just consider like this. Suppose you have any atmosphere and you have another atmosphere. So suppose this is hot atmosphere and this is cold atmosphere. So actually in hot atmosphere temperature is more, so the air molecule will be like away from each other, like they will be having more kinetic energy, so they will be away from each other. Away from each other means crowd will not be there, crowd will not be less, crowd will not be more, like because they are expanding, they are going, because of more temperature they are expanding, so they are taking more space. So it means what, for the given space crowd will be less. But just opposite here, when you will cool down the gas, then all the molecules will come closer. So in less given space more molecules can stay. So here more crowd, that's why density is more. So according to mathematical equation, you should bother your density is inversely proportional to 1 by temperature. So if temperature is more, density will be less, which is this is the case. If temperature is less, density will be more. This is the case. So this is very basic fundamental from thermodynamics. This concept we understand well in thermodynamics. Okay, yeah, next out. Yes. Very good. Okay. Yes. Okay. So see, now we'll discuss about humidity and its effect on the atmosphere. So let's understand what is the meaning of humidity. You might have heard that if you compare Chennai with Rajasthan, in Rajasthan you can take any, suppose yes, I'm recording properly. Okay, suppose we have two examples you take. One example you take Chennai and one example you take Rajasthan. In Rajasthan, consider Jaipur. So in Chennai and in Jaipur, if you compare, people say that Chennai is having more humidity. So atmosphere of Chennai is more humid as compared to the atmosphere of Jaipur. So what makes anything humid? So let's understand this. Imagine there is a person, and this person is sweating. So suppose water is coming on the body surface. This person is sweating. So water, the bubbles are coming on the body surface. Okay. So now see, actually in the air, in this air, you are having water molecules present. So these are your water molecules. So in the air, water molecules are present. Then I will say that this air is not dry air. It is actually humid air. Why? Because water molecules are present there. Okay. Now let's understand what is difference between dry air and hot and humid air. In dry air, you have only air molecules. What is air? Air means nitrogen and oxygen. Majorly I am talking nitrogen and oxygen. So suppose I am giving you one atmosphere. In this atmosphere, nitrogen and oxygen only are present, and I am giving you another atmosphere. In this atmosphere, nitrogen is present, oxygen is present, H2O is also present. So because of this H2O, this atmosphere you will say as humid atmosphere. But here you don't have atmosphere, H2O, so you will say dry atmosphere. So this atmosphere is dry atmosphere, but this atmosphere is humid atmosphere. Now, how will it affect? How will it affect? So see, actually if I am giving you some zone, in this zone, suppose you are imagining that 100 molecules will stay, and I am considering 100 molecules of air will stay. So actually there are 100 molecules of air. So actually what is air? Because I am saying 100 molecules, so around 80 molecules will be for nitrogen and around 20 molecules will be for oxygen. But imagine if I will add some 30 molecules of water, then in this 100 molecules of air, when 30 molecules of water will go, then some air will get displaced, because you have to adjust these 30 molecules. So after the addition of water in the given chamber, you have nitrogen also, oxygen also, and H2O also. So that's why earlier it was a dry weather, now it is a humid atmosphere. Earlier it was dry atmosphere, now it is humid atmosphere. So what is the sense of humidity? See, if any aeroplane is flying in dry weather, so on the wing your air molecules will flow, so lift will generate. But suppose in the atmosphere condition you don't have air molecule because of humidity, then this kind of atmosphere will disturb your flight conditions, because we are designing the aircraft for air, or you can say for air molecules, but because of the humidity, air molecules are present. So performance of the aircraft will change, because density of this new atmosphere will change. I hope you are getting what my logic is. Yeah, very good. So this is about the density part. See now, if suppose if a person is sweating, so if a person is like water molecules are there on the surface, on the body. So now actually what should happen when you are sweating, this water molecule should go away from your body. Okay, they should go away from your body. So how will they go away from your body? When the water molecule will come on the surface, I mean when we sweat, water molecule come on the surface on our body, then by using the heat of the body, this water can vaporize. Okay, so when this water will vaporize, it will take your heat and then only it will vaporize. Then only your body will feel cool down, because your body heat is going out because of this vaporization. See, point 1, in your body water vapors will come, I mean water molecules will come because of workout or something. Then because your body is hot, So because of the hot body, these water molecules will fly in the atmosphere. So you are releasing your heat in this case, right? So your body will cool down. So in this situation you will feel relaxed, you will feel calm, you will feel better, because whatever you are sweating, that sweat is going away. But now, second interesting point, where this sweat is going? Actually this sweat is going in the atmosphere. So if in the atmosphere already you have lot of water molecules, then it means what? I am trying to say, if this atmosphere is already humid atmosphere, then this atmosphere will not accept this incoming water molecules. So these water molecules cannot evaporate from your body. So you will not feel relaxed. So this condition is known as saturated humidity. What does it mean? Your atmosphere is completely saturated. Now any extra water molecule cannot go to the atmosphere. Atmosphere is completely saturated with water molecules. What is saturation? Saturation means the last limit. After that, other than that, extra we cannot accept. So what will happen? If the person is sweating in dry atmosphere, then easily these water molecules will go to the atmosphere and this person will feel relaxed. But if the same person will sweat but in 100% saturated atmosphere, in that case these water molecules cannot go in the atmosphere, because atmosphere is 100% saturated. That's why actually there is one rough data, around 30 degrees Celsius a person can die. Just around 30 degrees Celsius a person can die if the person will stay in 100% humid atmosphere. That's why whenever you will check on Google or somewhere, humidity of the atmosphere will be written. Like our atmosphere is how much humid today. So you can understand, whenever there is rain, after the rain atmosphere used to be somewhat humid. And this is a problem in your humid atmosphere. You cannot put your wet cloths in the atmosphere. Why? Because if you are putting your wet cloths in the atmosphere, like hanger is here, suppose you are hanging your pant and your shirt here, so and they are wet. So problem is, because already this atmosphere is, just imagine, 100% saturated humidity. So these extra water molecules from your clothes will not be accepted by the atmosphere. So you can never dry your clothes. Concept clear? Okay. No, never. Infinite time, never. Because the atmosphere is 100% humid. So these molecules will go where? There's no place for water molecules in the atmosphere. Yeah. Okay. Anything else I have to take? Okay. Then you have your another topic, airflow around the body. You have the another topic, airflow around the body. In your aerodynamics, I am telling airflow around the object, around the body. You just check this topic is correct or not. This topic is correct. Yeah, in your syllabus. It actually just now I saw before. Yeah, it is there. Because just starting your class, I opened your PDF, so I saw the topic. This topic was there. This is the next topic after atmosphere. Okay. So see, actually we want to analyze airflow around the body or around the object. So first of all, we should know what kind of object we are going to discuss. So mainly our object is going to be of two types. Either it will be in aerodynamic shape or it will be kind of bluff body. Bluff means the shape will not be aerodynamic shape. What is aerodynamic shape? Aerodynamic shape is this kind of shape. over which air can flow and complete the path smoothly. And what kind of object is bluff body? Suppose there's a plain plate. This plate is going in this direction. Then air will go and hit the plate and it will start curling like this. So this kind of situation is known as bluff body. So we have to bother about the aerodynamic shape objects and airflow around these type of objects. So because we have to discuss airflow, so we should know in the advance what are the types of air conditions are available. What conditions are like in the flow, what types of conditions are like general type of conditions. For example, Std flow, unstd flow, uniform flow, non-uniform flow. So these types of flow we will discuss first. So let's understand the very first type of flow, that is Std flow. What my point is, actually if there is any aerodynamic shape object, for example any aircraft with wing, tail and something, so whenever flow is going over the aircraft, total how many types of flows are there in aerodynamics? So that fundamental I will consider now. In that, first I am taking Std flow and unsteady flow. Std flow and unsteady flow. So let's understand what is Std flow. Suppose there is air flow happening over the wing. So I will just take the wing here and I am drawing a wing like this. So this airflow is happening over the wing like this. So I am just considering one platform here and one platform here. At this platform, suppose your temperature is T1. At this platform, your temperature is T2. And I want to know my flow is steady or unsteady. So steady flow means whenever there is a flow, that will be steady if properties like temperature, pressure, volume, density, enthalpy and blah blah things, properties will not change with time. Steady means properties should not change with time. Means if here temperature is 30 degrees Celsius, here temperature is 40 degrees Celsius, then again after 1 hour, after 2 hour, after 3 hour, after month, after year, temperature should be same. So if temperature is not being changed, we can also take example of pressure, density or anything. So whenever there is a property and if that property is not being changed with time in the flow, that kind of flow is known as steady flow. Otherwise it will be unsteady flow. Now see, you understand one small example. Suppose x is equal to 3 and I am saying x is constant. X is not changing with time. So x is not changing with time. So if you will differentiate this x with respect to time, like dx by dt, you will be getting 0. Because whenever we differentiate a constant value, we get 0. That's why if suppose there is any property P, this property can be temperature, this property can be density, this property can be pressure, this property can be volume, entropy, enthalpy, anything. So if the property is given and we need to check this property is the flow is steady or unsteady. So best approach is you should know the definition of steady flow. So definition of steady flow is like your flow should not change. Your property should not change in the flow with time. Means if you differentiate your property with time, it should be 0. At any coordinate I am talking. Suppose in the flow, I am considering one coordinate here. So suppose the coordinate is x1, y1, z1. Suppose another coordinate is here x2, y2, z2. So whatever property is here, suppose this P1 is P1. So this P1 should be P1 every time. Let the flow coming, no problem. Let the flow come and go, no problem. But this property P1 should not change. Here this property P2 should not change. Some students understand this in wrong way. Some student thinks that I am trying to teach this property and this property should same. No. I am not saying that. Try to understand. I am not saying that property should be same at every point. No. That is not my point. I am saying that whatever value you got at any location, consider this location. Fix that location. And let the time change. Let the time go. After certain time, you again come and check the same point. Their property should not change. Nearby properties change or not does not matter. That will not decide Std flow. To check the Std flow, property at a point, at a given coordinate should not change with time. Then only you will say steady flow or else unsteady flow. Clear? Very good. Now we go for uniform and non-uniform flow. So your first type was steady and unsteady. Now second type, uniform and non-uniform flow. So uniform flow, same thing. Suppose there is any object, suppose this aerofoil, and over that any flow is happening. So in this flow, at this point, if property is P1, then everywhere in the flow property should be P1. Everywhere property should be P1. If here temperature is 30, then everywhere temperature should be 30. If here pressure is 5 Pascal, everywhere pressure should be 5 Pascal. Then you will say, okay, everywhere property is uniform. That's why flow will be uniform flow. It means what? Because your property is constant now, but with respect to time. No, not with respect to time. With respect to location. Okay. So it means what? dP by dx should be 0. And what is your x? I am considering in x direction when you will move, your property change will be 0. You can also say dP by dy should be 0. It means when you will move in p direction, again change in property should be 0. Or you can also write dP by dz is equal to 0. So you don't write like this. Okay. All the coordinates you can write at a time using this concept. dP by ds is equal to 0. This s means it can be any axis, x, y, z, any axis. And this property, when you are checking, this property you should check at a time. Suppose right now if this is 6:30 am, then exactly at 6:30 am, check the flow everywhere. At this point also, at this point also, at this point also, and get the data of the property. Suppose we are checking density. At every point check the density. If everywhere density is same at the same time, then your flow is known as uniform flow. Now you understood uniform flow? Yeah, no. Actually, yeah, because till where flow is happening. Because we are discussing steady flow. So until you have flow condition, flow situation, right? Yeah, I mean to say, suppose in this pipe there is air flow. So I want to check this air flow, I mean flow. This flow is steady or not, uniform or not. So you should say that, okay, in the air flow, your property you will check at every different location. Don't check outside. You have to check inside the tube. Done? Okay. Now you got what is called like you understood what is the uniform flow, what is non-uniform flow. Then you should also understand what is steady flow, what is unsteady flow. If that is both are clear, then we'll go for third type of flow. That flow is known as laminar flow and turbulent flow. So laminar flow and turbulent flow is very interesting. Actually, laminar flow is very easy to guess. So I will explain what is laminar flow. See, actually, suppose you have airfoil like this, and if the flow is passing through, over the airfoil is smoothly and like a lamina. Lamina means plates, like one plate, another plate, another plate, another plate, like this. So this kind of flow is known as laminar flow. So how will you define this kind of flow? It's like fluid particles. Suppose here is any fluid particle. This fluid particle is passing through this path. Then whoever the next will be, it will follow the same path. Whoever the next will be, that will also follow the same path. It means laminar flow you can define as the flow in which fluid particles will move along a well-defined, I'm using a word, well-defined path. These well-defined paths you will say as streamline. So streamlines, they are actually straight and parallel. So that's why all these particles will flow smoothly on their particular streamlines. If there is any molecule flowing in this direction, this molecule will not jump in this direction. This molecule will, like, for every molecule there will be a defined path, like you have to go in this direction, you have to go in this direction, you have to go in this direction. No one will disturb other one. So that is known as laminar flow. So how will you guess laminar flow? For example, they do puja means worship in the temple. So you can see they are using agarbatti. Do you understand agarbatti? Yeah. So actually agarbatti will be like this. So there will be a black color stick, and then you will be having one holder here. So you will burn the stick here. So when you will burn the stick, then you can see that sometimes for certain distance smoke will be straight, and after that smoke will be like this. So until your smoke is properly defined path, this is laminar flow, and after that you will be getting turbulent flow. So what is laminar flow? Sometimes if you are if someone is smoking, then suppose here you have that burning part, and from here smoke is coming out. So you can see that, like, till certain distance smoke will be like in laminar, and after that the smoke will spread out like this. So it will become turbulent. So turbulent flow, what kind of flow? Particles will not move on a well defined path. Particles will move in zigzag manner. One will go here, one will go here, one will go here, one will go here, like that. So and whenever there is turbulent flow, then because of that zigzag motion, like they will do like this, like this, like this, like this, like random motion. It is a not defined motion properly. It is random motion. So you can say eddies will form. Eddies. What is eddies? Like this kind of situations will come. What I'm drawing on the screen, same type of situation will come. So this is a turbulent flow. Energy of the turbulent flow is very strong than laminar flow. In laminar flow you have less energy. So we will discuss one by one. So main thing is what kind of flow is laminar. That's all. Only this much is enough to know about laminar. And other than that you have turbulent flow. Now we can talk about who will decide laminar flow and turbulent flow. So there is a criteria. That criteria is known as Reynolds number. Reynolds number. Imagine a flow is happening in a tube. So your flow will be smooth, or in the same tube your flow will be turbulent. It is actually based on, and both the flows are going in this direction, then it is based on Reynolds number. So there is something called Reynolds number. This Reynolds number we use to define our flow is laminar or turbulent. Actually, for different flow conditions, we have set of Reynolds numbers. So for example, in this condition, the number is 2000. So if your Reynolds number you are calculating that is coming less than 2000, then the flow will be laminar. And otherwise, if your flow Reynolds number is more than 2000, then you can say it will be turbulent. Okay. Actually, in every special case, for example, just now I took cylindrical pipe. I can also take a flat plate. I can also take airfoil like this, and in this also flow is going, over the plate also flow is going, and over the airfoil also plate is going. You can also consider sphere, like over the sphere also flow is going. So in every condition there will be a range of Reynolds number. No need to remember the range, because there will not be question based on range. So suppose this is the R1 value, this is the R2 value. So if your Reynolds number for the given condition, actually you have formula for every condition, but as you said, you don't have numerical values, so no problem. So if your Reynolds number is less than R1, then this flow will be turbulent. And for this condition also, you have Reynolds number, suppose R3, R4. If your number is less than, because different shapes are having different values of Reynolds number to check whether flow is laminar or turbulent. Suppose you are talking about sphere, then again for this you will be having separate value like R5, R6 for the Reynolds number. So if your Reynolds number after calculation is coming less than R5, then your flow will be laminar. Otherwise, flow will be turbulent. I mean, if you are more than R, then turbulent. Or in between, what will happen in between? In between, flow will be mixed nature. That is known as transition. In that, your Reynolds number, I mean, some part will be laminar and some part will, I mean, you will be having both the natures. So yeah, so you can consider in case of a pipe, this range, I remember this is 2000 and 4000. So here you have 2000 range and here you have 4000 range. So if you are below 2000, then properly laminar. If you are in between, then it is neither laminar nor turbulent fully. It is kind of mixed flow. So it is difficult to study mixed flow, and otherwise you will be having laminar flow. Okay. Turbulent flow, yes. Now we go for compressible and incompressible flow. One more thing, at least this much basic you should know about laminar flow, about Reynolds number. That Reynolds number is actually a ratio of two different forces. One force is known as inertia force and one force is known as viscous force. So inertia force is force what we find with the help of F is equal to ma. And viscous force is having separate formula. So no need to go into this formula. This formula is very popular. F is equal to ma, force, mass, acceleration. That is known as inertia force. And viscous force they will be given. Anyway, I don't think they will ask you to calculate the Reynolds number. But idea is, yeah. So you should know one more fundamental about Reynolds number. In case of Reynolds number, your basic formula comes as rho v d by mu. This formula I am talking about whenever there is a flow in the pipe. Actually, it is not only based on Reynolds number. Reynolds number itself is based on these parameters. So if you have larger pipe or if you have a smaller pipe, according to that you will be having Reynolds number, because diameter is coming into picture, these diameters. So according to that your Reynolds number will be changing. How fast and how slow? V is the velocity, rho is density, like what kind of flow is it is oil or milk or water, like what kind of flow is flowing. Okay, so this is done. Now we'll go for another type of flow, compressible flow and incompressible flow. You see, these types of flows are possible over any object. Now compressible and incompressible flow, actually it is very easy to understand. What happens? Actually, imagine you have a cylinder, in that a piston is attached and inside that you have any gas. So because you are keeping the gas inside, so gas will be having some mass. So suppose that mass is m, and because it is closed in the volume, so volume will be v. So density is nothing but mass by volume, that is only kg per meter cube. Okay, now try to understand. If you want to compress this gas, then mass you cannot change because there is no leakage through which you can send the mass inside. But volume you can increase or decrease. So suppose if you are decreasing the volume, it means bring the piston down. So these molecules will come more closer. More closer means more crowd, density will increase. So in this example, I am increasing my density by changing the volume. But when we discuss compressible flow, then in the flow your density will change not because of volume but because of velocity. So this velocity concept we cannot understand in this example. So that's why we have the concept of compressible flow and incompressible flow. In case of compressible flow, whenever there is a flow, then if your density at every point is either increasing, keep on increasing, or keep on decreasing, then you will say density is not constant. Your density is not constant. So whenever in the flow density is not constant, it means density is changing. So we'll say compressible flow. So in compressible flow, your density will not be constant. It will keep on be changing. But if your flow is incompressible, then density will not change. Now here you should know two key points. If your Mach number of the flow is less than 0.3, then we consider density will not change. It means incompressible flow. But if your Mach number is more than 0.3, then you will definitely say that it is compressible flow. What is Mach number? I will explain later. In same way, there is one more way to say, in the flow, everywhere, whenever there is a slow speed flow or fast speed flow or fastest speed flow, in all the flows, in reality, density changes. Density will change for sure. But we consider if density changes only 5% or less than 5%, then we say that okay, density is not being changed. Then we say incompressible flow. We consider compressible flow if and only if your density is more than 5%. Not density, change in density. If the change in density is, what I mean, suppose your density was 100 and now density became 101. So how will you find the change? Change we always find out by this logic. Final minus initial by initial. So it is 1 by 100. So 1 by 100 means this 1 is 1, this by is per, and these two zeros are cent. So 1%. So this density is 1%. So 1% density we don't consider as change in density. Earlier density was 100, now density is 1, not 1. So we don't consider change in density because value is very less, that is 1%. It means till your density is not changing till 5%, more than 5% density change, then only you will say compressible flow. Okay. Then we go for another type of flow that is known as rotational flow and irrotational flow. So we'll understand what is called rotational flow. So there is a flow called a rotational flow and irrotational flow. So actually just imagine water flow. Water is flowing. Actually when water is flowing, then what is water actually? Water is nothing but water molecules. So water molecules are flowing in the direction. And actually what is water molecule? If you check out, it is H2O. And if you check out the chemical variation of H2O, chemical composition, then you have one oxygen and you have two hydrogens. So reality is this entire guy is a molecule. So this guy is actually flowing. So in the flow, if this guy is rotating, then you will say rotational flow. And if this guy is flowing without rotation, then you will say irrotational flow. It means fuel particles, they will flow of course, but at the same time they will rotate about their own axis. For example, if I will draw, this is one molecule, this is one molecule, and this is one molecule. So suppose this is point A and this is point B. So this molecule is going here, but this point is rotating like this. It means A came here and B came here. So you can see the rotation. And then again A came here and B came here. It means in the flow, this molecule is taking turn about its own axis. Where is the axis? This is the axis. So about their own axis, if molecule is changing, rotating, then only you say rotational flow. Otherwise you will say irrotational flow. In case of irrotational flow, molecules will not rotate about their own axis. Then we go for another type of flow that is known as 1, 2 and 3 dimensional flow. It is very, very easy. If your flow is happening only in x direction, then this flow velocity will have only x component in this direction. Then you will say one dimensional flow. But if your flow is happening in x direction also and in y direction also, it means your flow is happening like this, then you will say two dimension. If your flow is happening in 3D, Like for example, whenever you have fan, so from the fan your water will come down, air will come down, and your air will go like this also, like this also, like this also, like in all directions. So this kind of flow is 3-dimension flow. So it means what? Your velocity components, they are the functions of actually, because see, in x direction, in y direction, and in z direction, we will give velocity component as u, as v, and w. So u, v, w will be our velocity examples. So these all velocity components will change on x and y and z. Not only x, not only y, not only z. How will you understand simply? If you want to understand it simply, then you will say that okay, your flow is in 3D, and at the same time every velocity component depending on all the coordinates. When coordinate is changing, velocity will change in 3D. Done? It is not tough. This one is easy. Yeah. So now we go for stream tube, stream line, path line, streak line. These things, what are they? So types of flow over, but in that same type of flow you have there is something called subsonic flow, supersonic flow. That part I will take, but before that I have to show something called stream lines, stream tube, and path line. So what is that? Actually, suppose here the flow is entering and here the flow is coming out. So on the way, how a particular molecule has traveled. This molecule has traveled like this, or this molecule has traveled like this, or this molecule has traveled like this. Like what kind of path molecule has taken. So the imaginary line, actually there is no line, because whenever there is a molecule passing, they will not trace any trail. For example, you are breathing the air, oxygen and nitrogen is going into your nose. Are they drawing any path? No, they are simply going. Just for the understanding purpose of the student, we draw the path. So that's why we say imaginary line. So our next topic is streamline. So streamline is these lines. These lines are streamlines. So how will you define this? Actually, they are imaginary line in the flow field, because there is a field for the flow in which suppose this is the streamline and your flow particle is here. So right now your particle is having this to go in this direction, but when the flow particle will come here, it will be having tendency to go in this direction. When the flow particle was here, it had tendency to go in this direction. So you can see direction of the particle is changing every time. So this streamline is nothing but tangent on the particle. It's like there is an imaginary line in the flow field, right? And tangent to this line will give you the direction of the particle in a particular time. So how will you know streamline in simple? In simple, like it is just a path through which all the points will go. And what is stream tube? When you have flow like so many on so many paths particles are going, so you combine all these streamlines together, so that will be like a tube, stream tube. A stream tube is nothing but, like suppose if you have a pipe, in the pipe if you send the water, so water will go from everywhere, right? So it is like a streamline also and a stream tube also, because all the lines are together, so it is a stream tube. Then we go for path line. Another one. What is path line? PATH, path line. So path line is very interesting. Imagine from here you are starting and you are going like this, and you are reaching suppose here. So suppose at t is equal to t time you started, and you are reaching here at t is equal to t plus some small time t1, because when you will travel, definitely you will take some time. So in this change in time, in this t1 change in time, the path followed by the fluid particle is known as path line. Like exactly what was the path followed by the particle. Now see, exact path is known as path line. Now we should know streak line. These are the part of flow actually. Streak, because whenever there will be flow, either streamline or streak line or path line or all the three. What is streak line? A streak line means, just imagine from this tube, 3 particles are coming out from same position. So suppose one particle is going in this direction, one particle is going in this direction, one particle is going in this direction. So imagine at any time t, suppose 2 seconds, just after 2 seconds, suppose this particle, suppose the first particle reached here, second particle reached here, third particle reached here. So you connect these lines. So this black line is known as streak line. So actually a streak line is nothing but the joining of all the points at any instant. So that right now whatever I have done, I will say that as instantaneous picture of the positions, and we are connecting them. So it is known as streak lines. Line we are joining from where they are originated. So that's all. Concept of streak line over. Done? This was clear? Okay. Till now, any difficulty here? Yeah, in real life, any flow you cannot consider as incompressible, because density will change for sure. In real life, you cannot say that your flow is not irrotational. Every time flow is rotational, because you have viscosity. Viscosity means friction. Any time, like, assumptions will not work. In reality, when you will say that okay, flow is in 1D, no, flow is never in 1D. Flow is in 3D in real life. Yeah, so like these are the assumptions to understand. Like if I will say that okay, I have a flow condition, and in that flow condition I want to know my flow is laminar or turbulent. So laminar turbulent you can understand. Like I gave you the example of cigarette and agarbatti. In same way, if I'll ask my flow is Std or un-Std. So in real life, always flow is un-Std. Always properties will change. Properties will never be constant. Okay. So now whenever we talk about flow over the airfoil, these are the possible types of flows over the airfoil. Now you have to know subsonic, supersonic and hypersonic, these kind of flows. So just one more minute, then we can successfully cover. See now, suppose you have any particle. No, you go in this way. Actually, if your Mach number is the sound speed number. And what is Mach number? If you know the Mach number, suppose there is any object flowing in this direction and the Mach number is 2. It means what? This object is flying 2 times faster than the speed of sound. So Mach number is direct connection with the speed of sound. If suppose there is any aeroplane is going in this direction with Mach number 3. It means what? It is going faster than sound, 3 times faster. And of course, if suppose your Mach number is 0.5, it means Mach number is half. So half means if sound speed is going with 300 meter per second, then the object is going just 150 meter per second. So this is the Mach number. So according to the Mach number, we have classified the speed. What does it mean? If your Mach number is 1 and below Mach number 1, you will say subsonic flow. After Mach number 1, you will say supersonic flow. And after Mach number 5, you will say hypersonic flow. Okay. If your Mach number is 0.3, then all the Mach numbers less than 3 will not change density. So you will say incompressible flow. And after that, every one will change density. So they all are compressible flow. Now in this you have a special zone. There is Mach number 0.8 and there is Mach number 1.2. So from 1.8 to 1.2, this zone is known as transonic flow. Transonic flow. It means what? In this you will be having subsonic also and supersonic also. That's why we say transonic flow. Yeah. So this is transonic flow. Transonic flow means it is kind of a transformation. You have subsonic flow and supersonic flow. So subsonic flow is converting into supersonic flow. So it is kind of conversion. right? So this is all about types of flows, and I have recorded the video for one hour class, and this video I will immediately I'll put on the upload.